Assalamu alaikum dear students. Today we will introduce PNP bipolar junction transistor. If you have studied the NPN transistor, then you can do everything with the PNP transistor by just considering some changes. We will study PNP transistor in contrast with the NPN transistor so that you can understand what would be the changes you can make to handle PNP transistor. As we studied, a p-type, if sandwiched between two n-type transistor, it is called NPN transistor, right? In 2n region, one is called emitter, another one is called collector, and the center sandwiched part is called base, right? So it means this becomes emitter base junction, one diode. This becomes collector base junction, another diode, right? So if you make this emitter base junction as reverse biased and collector base junction also reverse biased by applying required polarity voltages at these three terminals, then you are basically in the cutoff mode. If you make this emitter base junction as forward biased, collector base junction as reverse biased, then you are in the active mode. If you set both the junctions as forward biased, then you are actually in the saturation mode. One more mode is when you make this collector based junction as forward biased and this emitter based junction as reverse biased. This is usually called reverse active. Why reverse active? Why not? This can also be used or said as active. It is because of doping difference between this n region and this n region, and also the size and structure, right? We did this about these things, just studied about these things earlier in detail, right? We will revise it here also, right? Same is the case when you sandwich an n-type semiconductor between two p-type semiconductors, then that transistor is called PNP transistor. One of the p region is called emitter, another p region is called collector, and the center sandwiched part is called the base. Obviously, in this diagram you can see these two regions seems to be same, so you can make this as emitter and this as collector. No, this is just to show you the sandwiching process, right? Otherwise this should be emitter and this should be collector, because structure wise, size wise, doping wise, these must be having their own specs. First see the currents and voltage relationship, then we will see the structure. In NPN transistor, we have studied that, for example, in active region, you must be having emitter base junction as forward bias, and this forward bias can be achieved if you make this P region as compared to this N region 0.7 more positive, right? So that's why you have a positive terminal here and negative terminal here. So this is forward bias, and now to make this junction as reverse bias, it means this N region should be more positive than this one, right? So it becomes reverse bias. So now because this junction is forward bias, so this diode will start conducting, right? Because this is an n-type semiconductor, it has electrons as majority carriers, so it will be dragged or drift towards the p region. Since p is very thin and lightly doped, some of the electron will combine with the holes, p types, majority carriers, holes, right? And also in the same way, the holes will be attracted towards the n region. In the p, the hole will drift towards the n region and combine there. So these two things will make the total base current. These two things, the hole current and electron current, will make the total IE, right? That is why it is called bipolar junction transistor, because in this transistor both the electronic current and the hole current exist, right? To make the whole current of that terminal or junction, right? So only a small part is combined here, right? The remaining part is actually being attracted. The electrons is being attracted by the high potential, positive high potential of this reverse bias collector base junction. And recall that we had these collector and emitter and base current relationship, right? Collector current is equal to the scale current constant for a transistor, temperature dependent constant, right? So it means we have a collector as a current source, behaving as a current source controlled by a voltage at VBE, right? And a part of VCE, right? Dependence of IC over VCE, that is called the early effect, right? So it means this formula is without the early effect. We started from here when we are studying the NPN transistor, but later when we did the small signal modeling, we and characteristics curves, we saw that collector current is not constant for VBE if you increase VCE, right? So that was called early effect. We did it, right? So similar here, because we are introducing the PNP, currently we are taking this collector current only depending on the VBE. It has small dependency on VCE, neglected at this time. So it means we are neglecting the early effect. Again, we can see that emitter current is equal to collector current and the base current, right? And IC is equal to beta IB and IC is equal to alpha IE, right? And what is alpha and beta? Beta is alpha upon 1 minus alpha and alpha is beta upon 1 plus beta. So alpha is less than 1 and beta is in hundreds. So this is the current flow diagram of PNP transistor. In PNP transistor, and if you want to run it in active mode, you have to make emitter base junction as forward bias. And to make emitter base junction of this PNP transistor, then it means this time you have emitter should be more positive than the base, right? You can see the polarity of this and this battery, right? VEB here it is called VBE. It means VE would be higher than VB to have this PN junction forward bias. Similar is the case here to make this junction reverse bias. This should be more negative than this one, right? Here you make this positive because of this PN junction. Again, because this junction is forward bias, huge amount of majority carriers, which would be holes here in the P region, will be pass through the base because base is thin, so a small amount of that hole will be combined with the free electrons, the majority carriers in n region to make a part of the base, correct, right? And in the same way, because of this negative polarity here, the electron majority carriers of this type will be injected into the p type where they combines to make another part of the base current, and these two combine to make base current, total base current. And here is the same case, the hole and electronic current combines to make the total emitter current, right? So because this base is thin, small amount of this emitter current will be collected at the base. The remaining huge part will be collected at the collector because of the attraction, negative attraction for the positive holes, right? So it will be swept about this junction, even it is reverse biased, right? So all these formulas will be affected or applicable for this PNP transistor as well. But remember here you should be having VEB, right? And this is the symbol of NPN transistor you already studied, right? To make this would be N type, P type, N type. To make this forward bias, this should be higher than this one. and to make this junction as reverse bias, this should be as higher voltage than this one. That's why you draw your NPN transistor here, emitter down and collector up, so that it has the higher voltage. It has a little lower voltage than collector, and it is more lower than the base voltage to have this forward and this reverse, right? And this is the structural difference between emitter base and collector. Emitter is very short in structure as compared to the collector, but is very heavily doped to emit more majority carriers. Base is thin and lightly doped to have small base current, and collector is very huge in area, so that it can collect more or most of the most of the majority carriers emitted from the emitter, right? And very moderately doped. So same would be the case in PNP transistor, because you have to make this junction as forward biased, and because this emitter here is P and base here is N, you have to make this emitter should be more higher than base, and to make this as reverse bias, you have to make your base should be higher than the collector. So means our emitter would be at the top of the page, base would be in the middle, and collector at the bottom, which is contrast to the NPN transistor, right? Now comes to the large signal and Abermore models of the BJT transistor. In the active mode, right? In the active mode, you make this base emitter junction as forward bias. It means it behaves as a forward bias diode, right? And collector base junction and reverse bias. In this way, the collector is basically becomes the current source, whose current, the collected current, is actually controlled by the emitter base to emitter voltages, right? So this is the collector current if you want to write in the form of this or in the form of this. So these both things are equivalent, right? But if you want to make base collector diode as forward bias, because here if you have NPN, you can make base as positive, whereas collector as negative, to make this as a forward bias diode and anticipate to have a current source at the emitter side, but it is not possible because your structure is not supported for this active region. That is why it is called reverse active. You want to have have the same functionality, but because of the structural and doping difference, this does not work as compared to the forward active region. So Abermore model said that anyone can connect in this way, make this as forward and this as reverse, or this as forward and this as reverse, right? So they give a combined model of Aber named as Abermore model of a transistor. Here is it is for NPN, right? We have studied this. I am just revising it to introduce the PNP transistor, to just show you that with the small difference everything are the same. So here you have this forward diode, right? Forward where it is here, right? And this one is here, right? So Evermore model said that you have a transistor of this kind. Now it depends on your polarity. If you make this as reverse bias, this as forward bias, your your transistor is actually configured in active mode, forward active mode. So this route will work and this will not, right? If you configure it into the reverse active region, then this route will work. Sorry, this route will work, right? You made collector based junction as forward bias, which is not supported by the structure and doping. So same is the case for PNP transistor. You would be having a base to emitter junction forward bias, to have a collector current source at the collector controlled by this VEV, right? So you can write this collector current in the form of this or in the form of alpha IE, right? But if someone configure oppositely to make this junction as forward and this junction as reverse, whereas the structure is not supporting and for this. So but still you are in